we are going to start our basic course on astrophysics, and I think you will be benefited from this course. So let's first start with the related topic of astronomy, right? And what is astronomy? Well, it is a branch of science which studies celestial objects and phenomena related to them. And if this is astronomy, then what is astrophysics? Well, astrophysics is a branch, a very small part, important part of astronomy, where we apply the various principles of physics to understand the nature of these celestial objects. So we apply various physics laws and rules to understand these celestial objects and also the phenomena related to them. Okay, fine. Now the next question is, how do we do this study? Well, regarding astronomy, you say it is an observational science as compared to other experimental sciences, where we can control the conditions of our experiment, right? Now, in this particular case, the experiments occur automatically. It is beyond our reach. Come on, we are not going to build the Jupiter in front of us, or we are not going to build a star. It is not possible. It is outside of our capability. It is foolish to think in terms of think like that. So what I mean to say, these experiments, they occur automatically, right? In stars, in the universe, galaxy and interstellar medium, and we observe them from our earth. Hence, the repetition of an experiment in other sciences, you see, this is important. So the repetition, what I am going to say is that the repetition of an experiment in other sciences is replaced by statistical study of large sample, and changes in experimental conditions are taken into account by observations of a large variety of closely similar objects. So this is how we do the study in astronomy. Now, what about astrophysics? In astrophysics, we have two very important steps, step 1 and step 2. In the first step, we observe all aspects of radiation emitted by celestial objects, and then this is collected by telescopes and later on analyzed with various instruments. Now, not only that, but also we observe the direction and amount of radiation, color spectrum and polarization of radiation, as well as changes in these quantities with time. So this is the very first step. In the second step is basically the interpretation of the observed data using the principles of physics. Come on, this is the topic is astrophysics. So we are going to apply the physics law. So in the second step, we are going to apply the principles of physics, and then we will try to extract the properties of the radiating celestial objects. So you see, the celestial objects, they are emitting, this is a child's view of a star, they emit photons, neutrinos and many other things, right? Now, whatever they emit and whatever we are able to capture, we will capture using our telescopes and all that stuff, and then another detectors, and then we will be able to extract, after using the physics laws, able to extract the properties of these radiating objects. And now, what properties are we going to talk about? We are going to talk about the first thing, which comes to mind is the distance. How far is this object compared to our Earth? Right? The next is the size, then mass, the amount of emitted radiation, luminosity, then temperature, chemical composition, what it is made up of, and whatever it is made up of, is it slowly changing with time? How are these things evolve with time? The age of the celestial object, the evolutionary history, and the origin of these celestial objects. And by doing this study, we are going to not only able to get a variety of new physics, but also we are going to test whatever physics we know. In fact, sometimes it helps us to unravel new physics. Say for example, dark matter. If we haven't studied outer space, it would be impossible to get an idea about the dark matter, which is still a topic of current research. Okay. Now, with that being said, let us now look at the night sky. So this is our night sky. What you can see, these are not just stars, right? There can be many things. These are basically celestial objects or heavenly bodies. Okay. Now, what do they comprise of? Well, we can have stars, planets, comets, interstellar dust, and many other possibilities. The first thing which comes to mind, come on, is it possible to count them with the naked eye? If we look at a clear night sky, of course. And don't think that this is a foolish question. A lot of people have done that. And a very long time before as well. And observations show that it is possible to observe roughly 5,000 celestial objects using just the naked sky. Okay. Now, what do we observe? Basically, if you use a telescope, then this is what you will see. This is an evening photograph. Okay. Now, not only you will be able to see the stars, planets, comets, meteorites, but also you see our Milky Way galaxy as well. This is very interesting. Now let me show you this video. You see here you can see at night, if you use a very good telescope, then this is what you will observe, our Milky Way galaxy, and these are the various other stars. But you need a very good telescope as that. And there are various other celestial objects as well. Here, you see. This is very interesting. Normally, we could not see this using our naked eye. But if we have a good telescope, it is possible to observe. You see, this is Jupiter, and then this is the daytime, again nighttime, a different orientation again. So basically, using this picture, you can understand that we are roughly on the far edge of the Milky Way galaxy. Okay, so this is very interesting. Constellations as well, we can observe other far away galaxies. Fine. So, what are we going to talk about? Basically, we are going to talk about the heavenly bodies or celestial objects, right? And we can have stars, planets, comets, interstellar dust, and many other things. In this course, we will talk about this as well, this topic, many other things. Now, how do we start our study? Well, the first thing we will do is we will start with the classification based on the laws of physics, right? This is just what we have discussed right now, how astrophysics study is done. And the most important thing is that, come on, we are not going to go with a rocket, go near a star and use our very basic touching techniques or so to understand its features. No. What we are going to do, we are going to use non-destructive techniques. And how are we going to do that? We are just going to observe whatever the star is emitting. Radiation, photons, gamma rays, neutrino, charged particles, neutrons, whatever thing, not just stars, many violent phenomena, whatever is happening, we cannot go over there. It is very, very far away. Come on, the nearest star, Proxima Centauri, is light years away, several light years, right? So it's just not possible. We do not have the technology and we do not have the time to do that. Come on, why do we do that when it is just possible to extract very simple, basic ideas about them just by observing the radiation? Okay, so the first thing we are going to talk about now is, what is a star? What is it? What do you think a star is? Of course, we do know that it's an astronomical object whose size is much bigger than our Earth. And basically, it is a luminous ball. You see, luminosity. It is emitting lots of photons, gamma rays and many other stuff. So basically it is a luminous ball of gas. Right, now this is a very big object. What happens to the fundamental laws? Here, gravitation plays a very crucial role. You see, so much amount of mass is here. And so, the star is held by gravity and not just by electromagnetic forces or strong interaction or weak interaction. It is held by gravity. And not only that, it is sufficiently massive that it can ignite the fusion of elements in its core over here. So, because of gravity it is held together, and because of the gravity as well, the pressure is very high. It goes on increasing towards the center, and this I will tell you later on in the course. We will be able to demonstrate this using very basic physics. And as a result, in the center the pressure is very high, and we can have ignition, right? We can have basically fusion of elements in its core due to the gravitational pressure. Thus, basically, it is the nuclear fusion reaction in its core which support the star against gravity. So, we have the force due to gravity, and again fusion reaction occurring at the center, and the pressure generated because of it, which can work against this gravitational force. Otherwise, the entire thing will just collapse. And I will show you later on, when I will talk about, when I will discuss nuclear astrophysics, that it will take roughly 30 minutes for the entire sun to collapse had there been no reactions going on. This is very startling. Now, so what is a star? We have basically two important definitions. The first is gravity, it should be held by gravity, and the second is fusion reactions should be there. Now, this definition, you see, it excludes objects like planets and comets. Why? Because they do not comply with fusion reaction. We do not have fusion reactions going inside the planets and comets. since the pressure is not that high much. Okay. Now, similarly, the first criteria of gravity excludes trivial objects which radiate, like glowing coals and so on. Okay. Fine. Now, you see, so this is a basic idea about a star. And so, how does the star's life begin? Well, it begins with the gravitational collapse of a gaseous nebula, where the material is basically composed primarily of hydrogen along with helium and traces of heavier elements. The total mass of the star, remember, is the main factor that determines its evolution and eventual fate. This is very interesting. A single parameter here, the total mass, this thing, the total mass. If mass is large, it will evolve differently. If mass is small, it will evolve differently. Now, for the most of its active life, a star shines due to thermonuclear fusion of hydrogen into helium. Because why? Why? Because the most of the part is hydrogen. That's why. And thereby releasing energy that traverses the star's interior and then radiate into the outer space, just as I have shown here. At the end of a star's lifetime, its core becomes a stellar remnant, a white dwarf, neutron star, and if the mass is sufficiently high, then it can become a black hole. Okay. Now, this is just, I have given you a basic flavor of what we are going to talk about in this course.